here this one is, we have a product, we have a quotient, and we have an embedded function. So there's lots going on here. So we're going to start with applying the quotient rule. Inside the quotient rule, we're going to embed the product and chain rule. Okay, so I'm going to start by differentiating the numerator. So I get 3 cos x plus 3x times negative sine x. Okay, so this represents the derivative of the numerator. Okay, inside that derivative, I've applied the product rule. And the denominator then is going to be so there's my product rule inside the derivative of that red function. Okay, and maybe I'll color code the red and blue as numerator and denominator. So there's my numerator, there's my denominator. Okay, so now I'm going to apply the quotient rule, which means I don't differentiate the numerator, and I differentiate the denominator. And as I differentiate the denominator, I have to realize that there is a function embedded inside, so I have to apply chain rule, differentiate the 3x squared. Okay, and then I'm going to square the denominator. I end up with 3x squared plus 4. Okay, so there's my derivative. Again, we can simplify this. It's not mandatory to, but it is not a bad idea to simplify when we can. So here there looks like to be a common factor of 3. I'm going to factor that out. I end up with, I'm going to keep this factor, cos x plus x or minus x sine x. Okay, times square root 3x squared plus 4 minus, looks like that's going to be x squared, so it's going to be 9x squared. Okay, and divided by, and then cos x in the numerator, and then the denominator is going to be, the 2 cancels out, so we're just left with 3x squared plus 4. Ooh, lots going on here. And I factored out the 3, so I need to make sure that I keep that as 3x squared. Okay. And again, in this case here, I'm not too sure how much this simplifying really helps. Okay, it probably is not a great idea because it's probably going to introduce possibility of errors in simplifying, but if you're good at simplifying, you should feel confident to be able to do this. We probably should, in this expression here, at least simplify the divide by 2 here and here and group our terms. But apart from that, this original derivative is probably good enough to use to work out, to solve problems or to find slopes.